Hello students, good morning. How are you all? So students, in today class, we will discuss linked list part 2, right? And in this class, we will discuss remaining operation on singly linked list and some singly linked list practice questions, okay? And singly circular linked list, doubly linked list, doubly circular linked list, and some PYQs, okay? Yes, good morning. Okay, very good. All is well. Okay, so let's start. Students, yesterday we have the last question. I think we have discussed the find the middle of the linked list, right? As a continuation, the next question is detect cycle in a linked list. I want to detect a cycle in a linked list. How we can detect? Yes, all is well. Very good. So this is very important question, student. Many of the placement companies ask this question in interview round. Okay. So what you have to do, you have to detect cycle, student. So this is a linked list and you have to detect cycle, whether cycle exists in linked list or not. Then how we can detect a student? What should be the logic for this? Yesterday we have discussed concept slow pointer and fast pointer, right? So look here, student. This is source and here this is destination, right, student? This is the start point and this is the end point. All right, student. There are no end point. So this is Mr. A. The speed of Mr. A is twice x, and speed of this x, right? If there is no cycle, this is an open path up to infinite, right, student? So both is just racing. So my dear student, is there क्या ये दोनों कभी मिल पाएंगे, right? So if 2x a come here, then b this one. Now sir, a this one and b like this one, right? So never meet, कभी नहीं मिलेंगे बच्चे, because there is no cycle, right? J and B room, yes. So A come fast, student, because and sir A and B never sir meet, sir कभी नहीं मिलेंगे दोनों, right, student? But my dear student, think about it. If there is a cycle, okay, and the speed is twice x, and speed is x. If there is a cycle, then sir, if if cycle, then at certain point after certain moves के बाद sir both sir A B को catch कर लेगा, right? Here, then B here, then A here, sir, then B, then sir A here, sir, then B. Now this one, then sir A here, then B this one. Okay. Now sir A and B certain some position. If this is a cycle, then B A को catch कर लेगा, right? So this is the concept, student. Okay. So then just use slow and fast pointer concept, okay, and write code for this. Define is a keyword for function define. Detect cycle, student. Detect cycle in a linked list, and self is a parameter. Okay. Slow equals to, initially बच्चे slow pointer equals to fast pointer equals to what? Self dot head. Both is pointing to same location, right? Self dot head. Sir, means what? So slow and fast both is pointing to this location. Slow is 100 and sir fast is 100. Initially both is pointing to same location, right? And now apply loop fast and fast connects while fast and fast connects fast next not equals to null, not equals to none, then slow is moving, slow equals to slow dot next and fast equals to fast dot next dot next. Fast pointer moving double speed as compared to slow pointer, student. Okay. So my dear student, here fast is what, sir? 100 and fast connects is 200. Then slow equals to slow connects. Then slow equals to slow connects. Slow come this position, and fast equals to fast connects, right? So fast next connects, fast connects 200, this connects 300. So fast pointer come at this position. So this is a loop. After this, you again go to this while loop, again check. Fast is not none. Yes, fast is not none. Yes, because it is 300 and fast connects is not none. Yes, fast connects आगे गड्ढा नहीं है sir. You can move ahead sir, no problem at all. आप आगे जा सकते हैं. Fast connects not equals to none. क्या है 400. So slow equals to slow connects. So slow is moving to sir this one, and fast is fast connects. Fast connects. Fast is come at this position. Okay. Again go to this while loop. Fast and fast connects not none है. Yes, fast is 500. Fast connects क्या है 600 है. So slow equals to slow connects. Slow is come this position and fast is come to this position, right? Fast connects. In the next iteration again sir slow come this position and fast come at sir this position, right? In the next iteration slow come at sir here and fast come at this position, right? This one. In the next iteration slow come at this position and fast come at this position, right? Again this fast come at this position. So you can check out sir slow and fast both is pointing to same. Okay, my dear student, if slow equals to fast, if this condition is satisfied, slow equals to fast, every time check slow equals to fast. If this condition is satisfied, then what does it mean? Cycle detected, student. Cycle detected. Sir, if cycle detected, then your work is completed. हमारा काम complete हो गया है. Return true. Return true, or you can return slow pointer or fast pointer, right? Sir, if this condition is after completion of this loop, this condition is never true, then what will happen, sir? Then return what, sir? False. It indicates there is no cycle. After completion of this loop, अगर cycle नहीं मिला, तो it return false. It indicate what? No cycle, right? So in this way, you can detect cycle, student. Okay. Okay, dear student. Thank you, उद्धव. आपका भी thank you. आपने भी appreciate किया. Thank you. So in this way, you can detect cycle, student. What is the time complexity for this? Sir, you are just moving this loop. This is a loop, student. So that's why the time complexity of this code is what? what is this happening here, sir? This is a loop, student. So the time complexity equals to what, sir? Order of n. Okay. Now, sir, I want to detect the first node of cycle, student. Then how we can detect? Understood. The another question frequently asked in interview round. I want to detect the first node of the cycle in single linked list. How we can detect it, student? I want to detect the first node of the cycle, student. Detect first node of the cycle, student. Now, detect first node of the cycle, student. Detect first node of cycle. How we can detect it, student? Say something. Detect first node of cycle. Sir, first you have to detect cycle. Detect first node of the cycle. So, bache, you have to detect cycle. In this way, you can detect cycle, student. First, you have to detect cycle. In this way, you can detect cycle. When cycle is detected, then just break, right? A cycle is just break from this loop, student. And again, slow equals to self dot head. Slow equals to what, sir? If cycle is detected, then slow equals to self dot head, bache. Here slow ko I am taking as student, so slow equals to self dot head, right? So again slow pointer this you can write here slow as well as fast, student. When cycle is detected, this break keyword, you exit from this while loop. So if you exit from this while loop, then write from here, student, slow equals to indentation proper. So right here, slow equals to self dot head. So again, slow is set to here, self dot head. Okay. Understood, student? Now apply while loop, again check, sir, again, sir, while up to slow not equals to fast. If slow not equals to fast, student, and again check slow not equals to fast, move both together, both pointer together, student. Slow equals to slow connects, fast equals to fast connects. Okay. Slow equals to slow connects, and fast equals to fast next. Okay, so in this way, right here, slow equals to slow next, and fast equals to fast next. So slow not equals to fast, yes, slow not equals to fast, then slow not, equals to slow next. So slow come at this position, student, and fast come at this position. Sir, this is a while loop. Again go to this, you are again go to this while loop and check again condition. Slow not equals to fast, yes, slow not equals to fast, then slow equals to slow connects, fast equals to fast connects. Then slow is pointing to this one and fast is pointing to this one, student. Okay. Now again go to this while loop, slow not equals to fast, no sir, slow equals to fast. It means this is the first node. If both is equal, both is come at the same position, if slow equals to fast, it means this is the first node of the cycle. आप देख सकते हैं बच्चे, this is the first node of the cycle. Okay, this is what, this is the first node of cycle. Okay, so this is first node of cycle. Okay, then return what? This is first node of the cycle. Return slow or fast, anyone, right? You can return here either slow or fast. This is the first node of cycle, student. Okay, cycle start node, first node of cycle. Understood? Dear student, is this code is completed or something missing? This code is completed or something missing? Lucky, Uddhav, Sidhu. This code is completed or something missing? Say something. So this is not completed. Let's suppose if there is no cycle, then what will happen is, student, if this condition is never true, so slow equals to fast, then what, sir? After completion of this while loop, then write here else. Else, do you know while else? We have already discussed while else. Else what, sir? Return none, no cycle. Return none. It indicate what? No cycle. It indicate first node of cycle. Okay. And what is the time complexity? Again, sir, time complexity, first you have to detect a cycle, so time complexity is order of n. Okay. Now next question, your homework question for you. Count the number of node in the cycle. Count number of node in the cycle. This is homework, student. Count number of node. Okay, this is homework for you. Try yourself. Okay, count number of node in the cycle. So in this way you can detect cycle, student. Now this is completed. Find the merge point of two linked lists. I want to find the merge point here. This is the first linked list and this is the second linked list. And what is the time complexity for this? I want to find the intersection point or merge point of two linked lists. What is the time complexity of this? How it lucky, my dear student. First you are detecting cycle order of n. So this is also parallel loop. This is also motamati if I talk about. So this is also order of n if I talk about on an average order of n, right? So both order of n plus order of n, it will be order of n to n. Okay. Both is parallel loop. Lucky. Understood? Okay. Now next question, I want to find the intersection point of two linked lists, merge point of two linked lists. This is the first linked list and this is the second linked list. This is the intersection point. How we can detect this intersection point and what is the time complexity for this, student? Yes, student. My dear student, this is L1 linked list and here this is L2 linked list. I want to find the intersection point. So, sir, kaise? So first find the, there are various method, various logic, student. You can take many logic, student. So first find the length of first linked list, student. Find the length of first linked list, right? Let the length of this linked list is m. Okay. And find the second linked list length. Let the length of second linked list is n, student. So first linked list length kitna aaya? Sir, count the number of node in first linked list. 3 into this is 5. And n is second linked list number of node, sir, 4. Okay. And calculate the difference, bache. Calculate the difference equals to, if L1 is greater than L2, then L1 minus L2. If L2 is greater than L1, then L2 minus L1. So basically, आपको क्या लेना है? Positive value. So it will be what, student? 1. So D equals to, this is the step, sir, D equals to 1. Sir, which list is larger? Sir, L1 is larger. L1 length is larger, L2, right? Then first move L1 list D step, right? L1 list को D step move करा दीजिए. Okay, student. So here this is the one pointer P. Set one pointer P here and set another pointer Q, this one here. So D one step move larger list. So D step. So larger list only one time move. So P को move किया, then P come at this, right? One step. Understood? And after this, both pointer P and Q move together, right? Both pointer P and Q move together, right? And check if both P equals to Q, right? So both move together. If P not equals to Q, while loop लगाइए. While loop P not equals to Q, move P बराबर P का next, P equals to P next, Q equals to Q next, right? If both meet, right? Next step में P come at this place, sir, both move together. In the next step, sir, P come at this place and Q come at this place. So both come at, are equal. Then return, this is the merge point, student. This is the merge point. What is the time complexity for this, student? What is the time complexity for this, student? If I talk about time complexity, so time complexity equals to total time. First total time, I find the length of first linked list, length of second linked list. So order of m plus n, and after this you are just moving this. So this is the time complexity. If both list size is same, then answer order of n हो जाएगा. So this is the time complexity. Understood? Find the nth node from the end of the linked list, student. So here I am talking about single linked list. Single linked list have only forward pointer, right? So this is single linked list my dear student, so let the address of this node is 100 and this is 200, 300, 400, sir 500, 600, 700, सर 800 डॉट डॉट मान लो कितना भी है 1000, 2000. Okay, this is the data part. Let's suppose sir A, B, C, D, let E, F, G, H, like that. कुछ भी हो सकता है बच्चे. Let okay. And the next part contain the address of next node 200, and this is pointing to 300. This is pointing to 400. मान लेते हैं कि यहाँ पे जो भी है मान लेते हैं कि 900 होगा. Okay. And the last one, this is what, student? None. So this is a single linked list, bache, and single linked list have only forward pointer. You can move in forward direction, not in backward direction. In single linked list, you can move in forward direction, student, not in backward direction, because you have only forward direction. आपको आगे जाने का रास्ता पता है, पीछे का नहीं है बच्चे, right? In single linked list, you can move in forward direction. Sir, you can move in forward direction, but you cannot move in backward direction. But the question is, find the nth node from the end of the linked list. Sir, find the nth node from the end of the linked list. How you can detect this is the nth node from the end of the linked list, and what is the time complexity for this? Okay. Yes, student, tell me. And what should be the logic for this, student? You can move in forward direction, student, but you cannot move. Problem is this, sir, you cannot move in backward direction, right? Because this is a single linked list. But the question is, find the nth node from the end of the linked list. Yes. What is the time complexity for this, student? For this student, take two pointer concept, right? Two pointer P and Q. Take two pointer P and Q. P pointer Q and Q. First move n step. First move one pointer. First move one pointer n step. Right? N step. Okay, student. Move n step in forward direction. Sir, this move n step in forward direction. Now, after this move, Q come at this position. Let's suppose Q come at this position, right? Fine, student. And after this, both pointer move together. After this, both pointer move together. Sir, after this both pointer move together, then sir, in the next step, sir, P come at this position. In the next step, sir, Q come at this position, right? Like this. Sir, when Q and Q come at this position, then P definitely come at the nth node from the end of the linked list, right? Nth node from the end of the linked list. Sir, which node? I don't know, but 100% Q point at the nth node from the end of the linked list. Let's suppose this node, nth node from end of the linked list. So what is the time complexity for this? You are scanning entire linked list, na? So the time complexity is what, sir? Order of n. But the procedure is this. So time complexity is order of this. Yes, there are n number of logic, Lucky, n number of logic. Subtract length of the linked list after finding the name node. Yes, definitely you can do this, right? Or you can do this like this is the optimized version. In single scan, you can find the nth node from the end of the linked list. All right. So what is the answer for this question, student? This type of question may be asked in GATE exam. Okay. There's a pattern of GATE, student. So tell me what is the right answer for this question? Yes, student. This question is saying the following Python function take a single linked list as input argument. It modify the list by moving the last element to front and return the modified list Some part of the code is left blank. What is this code, student? ये blank code क्या होगा? So let I create some linked list, student. Okay, and this is head. So head is pointing to this one. Okay, and here data part 200. Understood. So ये question, this question is saying what? This question is saying कि sir, the following Python function take single linked list as input argument. It modify the list by moving the last element to the front. You have to move this last element at front, student. This last element at front, student. Okay. And return the modified list. You have to return the modified list. Some part of the code is left blank. ये कह रहा है I have to sir 20-30% completed, but some part this code is missing. You have to tell this missing code. Okay. So Q equals to क्या है? Q equals to initially null. P equals to self dot head, student. So P equals to self dot head. What is self dot head? Sir 100. So this is pointing to this one, and Q equals to none. Now while P dot next is not none, yes, P dot next is 200, not none. Then Q equals to P, and P equals to P का next. So P equals to P equals to Q. ये है बच्चे, initially Q equals to none, P equals to self dot head, and P dot next not equals to none. Yes, this is 200. Q equals to P. Sir, Q equals to P means what? Sir, 100. And so this is pointing to this one, and P equals to P connects. So this is cut it, and this P is pointing to this one. Okay. Now this is a while loop. Again, go to this side, and P dot next is not equals to none. Yes, P dot next is not equals to none because P dot next is 300. So again, move forward direction. One pointer next and previous pointer. Sir, Q equals to P हो जाए. Sir, Q equals to P means 200. So this is pointing to this one, and this is P connects 300. So ये इसको point कर रहा है, right? In the next step, one more step. So sir, P is pointing to, in the next step, P is pointing to this one, and student Q is pointing to this one. All right. In the next step. So fine. So my dear student, after this loop, sir, P is pointing to last node and Q is pointing to second last node. Now what you have to do, student? Sir, you have to move this pointer at where, sir? In front. So if you move this pointer in front, then first what you have to do, sir, this become the last node and this become the last node. So Q dot next equals to what, student? Q dot next equals to none. So Q dot next equals to none. So this connection is disconnected, and this become the first node, student. So P is pointing to this one. So then P dot next क्या हो? Sir, self dot head. P dot next equals to, sir, self dot head. If P dot next equals to self dot head, then self dot head is 100. So this is 100. So this node is pointing to what, sir? This node is pointing to this one. Understood. And one more thing, self dot head, this become the first node. So self dot head equals to P. Self dot head equals to P. So self dot head equals to P. What is P? Sir, this is 400. So this this self dot head is pointing to first node, and right, ये connection टूट गया बच्चे यहाँ से, and this pointing to this one, and this pointing to this one, this pointing to this one. So this is the left code, student. So check which option is matching. Q equals to none, no galat. Q dot next none, this one, and P dot next equals to self dot head, and self dot head equals to P. I think this one B is the right answer for this question. What about some saying C? C not correct, bache. B is the right answer for this question. All right. So now come to next question. The following Python function take a single linked list of integer as a parameter and rearrange the element of the list, right? The function is called with a list containing the integers, this one, in the given order. what will be the content of the list after the function complete execution? After complete running of this code, list कैसी दिखेगी आपको बताइए. ओके, सो इसका आंसर बताइए बच्चे. So this list is given 1 2 3 4 5 6 7. You have to apply this code. After completion of this code, list look like this. Sir, which option is correct? And the data is what, sir? Data क्या दिया गया है? 1 2 3 4 5 6 7. And one more pointer head. Sir, head contain what, sir? Sir, 100. So this is pointing to this one. Okay. So rearrange this one. Sir, this condition for what? If either head list is empty, if list is empty or list contains single node. This condition true when, sir, either list is empty, sir, self dot head is null, list is empty, या फिर list contains single node. Then in this case return. Otherwise p equals to self dot head and q equals to self dot head dot next. So p equals to what, sir? P equals to what, sir? Self dot head. What is self dot head, sir? 100. So this one is pointing to this one, and q equals to self dot head dot next. Q equals to self dot head dot next. Self dot head dot next is what, sir? 200. Okay, this one. So while q is not none, sir, q is not none. Yes, q is what, sir? 200. This is not none. Then p value and q value क्या हो? Swap हो जाए. P value and q value is swapped. Okay. So p value and q value is swapped. So this one is 2 and this one is, sir, 1. And after this, what, sir? P equals to q connects. Sir, P equals to q connects. It means P equals to q connects is what, sir? Sir, 300. This q next, P is pointing to this one, right? P is pointing to this one. Understood. So after this, this connection is disconnected. And sir, what is q? Sir, this is a ternary operator. If P is not none, yes, P is not none, then this condition is true, right? This condition is true, na? P connects. So q equals to क्या हो जाए? Sir, P connects is what, sir? 400. So this connection is disconnected and P is pointing to this one and q is pointing to this one. Okay. सो ये ऐसे नहीं होगा बच्चे, जस्ट मिनट। P is pointing to QNS 300 and this is connects 400. Okay, so ये connection आपका break हो जाएगा. This connection is break. Okay, if this connection is break, then sir, this is P is pointing to this one and Q is pointing to this one. Okay, so this is a loop, student. After this line, you again go to this while loop and check Q not equals to none. Yes, Q not equals to none. Again, Q is what, sir? 400. So again, P value and Q value swapped, right? P value and Q value what, sir? Swapped. So P value Q value क्या हो जाएंगे, sir? Swapped हो जाएंगे. So this is 4, student, and here this is 3. And after this, sir, P equals to Q connects. Sir, P equals to Q connects is what, sir? Sir, P equals to Q connects. Q is 400. Next is what, sir? 500. This is 500. Understood, student? And sir, if P is not none, yes, P is 500, not none. So if true पे होगा तो ये result आएगा, right? If true, then not none value क्या होगा? True होगा. एंड फॉल्स पे क्या आ जाएगा, सर नन आ जाएगा. सो P इज नॉट नन ट्रू है तो Q इक्वल्स टू P कनेक्ट्स. P कनेक्ट्स 500 नेक्स्ट इज व्हाट, सर? 600. सो इफ दिस इज 600, then this 500, this P is pointing to what? Sir, P is pointing to this one, and this 600, this is pointing to this one. Okay, and again go to this while loop and check Q not equals to none. Yes, Q is 600 not equals to none, and then swap P value and Q value swap, student. So P value and Q value, this is swap. This is 6 and here this is 7, right? नहीं 5 है ये. Sorry, correct it. This 5. Again go to this while loop and अच्छा swap हो गया. Then P equals to Q connects. P equals to Q connects. P is what, sir? P is Q connects, sir, 700. And check here, sir, P is not none. Then Q equals to P connects. P connects is what, sir? Q is connects 700. Next is what, sir? None. 700 next is none. Again go to this while loop and check Q. Q is not none. No, Q is none. Condition false, बाहर निकलेंगे. After this you look like, sir, लिस्ट को चेक करिए बच्चे, किस तरह का लिस्ट है ये. अब कैसा दिखेगा आपको, सर? 2 1 2 1 4 3 6 5. एंड क्या ये 7 हो पाएगा मॉडिफाई? नो. सो दिस इज द आंसर. ओके, दिस इज द आंसर. सो राइट आंसर क्या होगा बच्चे इसमें? डी होगा, राइट? मैंने इसको थोड़ा सा मॉडिफाई किया है, राइट? जनरली ये आंसर बच्चे बी लगा देते हैं, थोड़ा सा मॉडिफाई किया है, तो लिटिल बिट केयरफुल अबाउट कि ये नहीं है पूरा मैच कर रहा है. लास्ट वाला देखिए, लास्ट में ये डिफरेंस आ रहा है. ओके, दिस इज आंसर, राइट? सो डी, नन ऑफ दीज, दिस इज द आंसर. ओके, चलिए बच्चे, व्हाट इज द आंसर? सर nth नोड वाला कॉन्सेप्ट एक बार फिर से. nth नोड उद्धव, I think you are confused कि n-1 move, first move n-1 or n-2. I think you are confused in this. So basically, just उद्धव, आप ये था ना, क्रिएट सर, मान लीजिए 8th लिस्ट. तो सेम concept you can apply. Sir, both P and Q both is set to here, and n equals to, in this question, n equals to 8. Okay, so find second node, third node from the last. थर्ड नोड फ्रॉम द लास्ट कैसे सर पता चलेगा? बोलो भाई. सो उसी में कंफ्यूज हो रहे होंगे ना सर. क्यू को n स्टेप, 3 स्टेप आगे चलाया, 1 2 3, क्यू यहाँ आ गया, राइट? क्यू यहाँ आ जाएगा, या n-1 स्टेप. अगर क्यू यहाँ आ गया, इसके बाद दोनों को साथ साथ चलाएंगे this one, sir this one, sir this one and this one. Yes. Q को पहले 3 स्टेप आगे चला दिया बच्चे, 3 स्टेप इधर देखो सर, 1 सर 2 एंड 3, सर Q यहाँ पे आ गया ना। अब इसके बाद दोनों पॉइंटर को साथ साथ चलाइए। नेक्स्ट केस में सर P यहाँ आ गया, सर Q यहाँ आ गया, फिर मूव सर P here and Q here. Next sir P come at this position, Q at come this position. In the next case sir P come at this position, Q come at this position. You can check out this is the third node from the last or fourth node. So एक ज़्यादा चला लो भाई, अगर ऐसा कुछ हो रहा है तो एक ज़्यादा चला लो भाई, उसका नेक्स्ट वाला हो जाएगा, राइट। अल्टीमेटली द क्वेश्चन, दिस क्वेश्चन इज आई एम आस्किंग यू अबाउट द टाइम कॉम्प्लेक्सिटी। ओके, yes student, what is the right answer for this? P be a single linked list and Q be a pointer to an intermediate node X in the list. What is the worst case time complexity of the best known algorithm to delete the node X from the list? Okay. Here this is data part. Let's suppose A, B, C, D, E and F. Okay, sir, I want to delete this node student. I want to delete this node. So I want to delete this node PTR. This question is asking P be a single linked list and Q be the pointer to an intermediate. This pointer name is Q student. This pointer name is what, sir? This pointer name is Q. Q be a pointer to an intermediate node X. This node name is what, sir? This node name is X student. This node name is X. Okay. What is the worst case time complexity of the best known algorithm to delete the node X from the list? मुझे I want to delete this entire node from the list. Then what is the time complexity student? Sir, how to take question as 3? There. Q. Intermediate node, you can know, you are asking about this question, Lucky. You can choose Q either this one or this one or this one. Okay. Sir, I want to delete this node. Then what you have to do is, student, what you have to do is, student. Sir, you have to traverse this linked list from here. क्या हुआ ये? ओहो. You have to traverse this linked list up to here. Sir, traverse. You have to traverse this linked list and set one pointer. Let PTR. You have to set one pointer. So you have to traverse. And the cost of traversal on an average, this is order of n. Now, if you want to delete this node, then what you have to do, sir, PTR के next में, sir, PTR का next equals to what, sir? PTR का next equals to, sir, Q next. Sir, PTR का next equals to Q next is 500. So this is 500. So this one is pointing to this one. Okay, this connection is disconnected. If there is no reference of this node, then Python garbage collector automatically delete this node. Okay, so pointer adjustment, this pointer traverse की cost ये है, pointer adjustment की cost, this is constant. So total time equals to traversal cost plus pointer adjustment cost. So traversal time is order of n and pointer adjustment cost order of 1. So it will be total is order of n. So this is correct, student. If you delete entire node, then A is the right answer for this. Now, sir, if this question to delete the data, if this little bit I have modified this question, student, to delete the data, at node X, I want to delete data, not entire node, student. Then in this case, what is the time complexity, bache? I want to delete the data, this D part, not entire node. Yes, student. I want to delete D only, not entire node. In the previous case, I want to delete this entire node, but in this question, I want to delete this data in this node. Then what is the time complexity for this, student? Dear student, take one pointer, what, sir? PTR. PTR equals to what, sir? Q dot next. So PTR equals to Q dot next, then PTR is pointing to what, sir? This 500. And then override data, this override data here, and this override in here, student. Sir, how we can overwrite? So just write, sir, Q dot data equals to Q के डेटा में क्या आ जाए, सर? PTR डेटा, Q के डेटा में PTR डेटा, right? And Q का next equals to PTR next. Then what you are doing, sir? Sir, Q के डेटा में इसका डेटा आ गया, that is E, and the next part of this Q dot next equals to PTR next is 600. So this connection is disconnected and this one is pointing to this one, right? And Python garbage collector automatically delete this node, right? So you feel just like a data is deleted, but actually you have to delete as a next node you deleted, right? So what is the time complexity for this, student? Order of 1. Order of 1 constant. But this concept is not work for every node. This concept will not work for last node. So in this case, the answer is, sir, order of n, but this concept is not work for last node. Okay. Understood? लकी इसमें हमने वैसे ही ले लिया बच्चे, राइट? कौन सा क्वेश्चन था वो? एक जनरल एन इक्वल्स टू, मैंने कहा थर्ड नोड फ्रॉम द लिस्ट, आप 4 ले लीजिए, 5 ले लीजिए, ओके, n-1 ले लीजिए, n-1 स्टेप बच्चे, क्यू को क्या ले लीजिए? थर्ड नहीं लीजिए। अगर मैं आपसे कहूँ थर्ड नोड फ्रॉम द लिस्ट, देन क्यू को n-1 ले लीजिए, n-1 मूव अहेड कर दीजिए, उसके बाद साथ चलाएंगे तो आप nth नोड आपको मिल जाएगा, ओके। So, बच्चे, what is the right answer for this question? Consider a single linked list where f and l are pointed to the first and the last element respectively of the linked list. The time for performing which of the following given operation depend on the length of the linked list. Yes, student. Which operation depend on the length of the linked list, student? So delete the first element. No, it is not depend. Direct f equals to f connects. You have two pointers, front end, last node, first node ka address and last node address. Sir, this question is asking the time for performing which of the given operation depend on the length of the linked list. Delete the first node. No, sir. You directly f equals to f connects. Interchange in the first two element. No, sir. Swap kar dijiye. No, this is not answer. Add an element at the end of the linked list. Just allocate memory, bache. Just allocate memory for a node, and l dot next equals to this node. Let this is a ptr. L dot next equals to what, sir? ptr. So it is not depend on length. So D is not right. What about C? Delete the last element of the list. Sir, for deleting the last element of the list, you have to traverse. You have to traverse from here to here because this is a single linked list. You can move in forward direction, but you cannot move in backward direction, right? If you want to delete last node, then you have to set one pointer at the previous node, na? How, sir? I have, sir, last pointer address. Still, you cannot move in backward direction, student. So you have to traverse from here to here. The length of the traversal cost is order of n, right? Length, and set one pointer ptr, and just change ptr connects equals to none. So this C is the right answer for delete the last element of the list. Okay. अंडरस्टूड. सो ये हमने कल कर ही लिया था. ट्रेवर्सल का है सर, बेस्ट एल्गोरिथम फॉर प्रॉब्लम थीटा ऑफ एन टाइम. ट्रेवर्सल नहीं है, रिवर्स का है बच्चे, रिवर्स का है. कल हमने ये क्वेश्चन देखा था. ओके. नाउ सिंगल लिंक लिस्ट टाइम कॉम्प्लेक्सिटी बच्चे. नाउ डिस्कस सिंगल लिंक लिस्ट टाइम कॉम्प्लेक्सिटी. Only head pointer given. If only head pointer given, then the time complexity for single linked list, I want to insert at beginning. Sir, beginning से insert के लिए क्या होगा? Already we have discussed no loop. Sir, order of one. Sir, beginning से delete के लिए क्या होगा? Sir, order of one. We have already covered, right? Sir, ending से लिए you have only one pointer, which is sir head pointer. For head pointer के लिए you have to traverse the linked list. If you want to insert at end, if you want to delete at end, then in both cases you have to traverse the linked list, and the cost for traversal is order of n, right? And plus cost of pointer adjustment. Okay, so this is order of n. What about mid, bache? What about mid? If only head pointer given, then what about mid? Sir, mid के लिए you have to traverse half of the list, student. So order of n by 2 is order of n. So this is order of n. Sir, what happened if we take two pointer, right? What will happen if we take two pointer, student? Head and tail. If both head and tail pointer given. If both head and tail pointer, if both head and tail pointer given, then beginning, sir, beginning and mid, बच्चे, what is the time complexity? बताइए. If both head and tail pointer given, then what is the time complexity for this, student? Okay. if both pointer head and tail given, then sir ये order of 1 हो जाएगा, beginning से insert, beginning से delete तो order of n. Sir end के लिए if both head and tail pointer given, then no need to traverse. In this case, no need to traverse. So insertion in order of 1, right? What about this one, student? Deletion. If both head and tail pointer given, then what about deletion, student? न्यूज बस्टर आए या नहीं आए? वेयर इज न्यूज बस्टर? बोलो sir. If two pointer given, head and tail both pointer given, then what is the time complexity for delete from end, student? My dear student, look this question. So both pointer is given, student, front and rear and front and last. I want to delete this node. Then you read what, sir? You have to set one pointer at the previous node, student. But सर क्या आप इससे पीछे आ सकते हैं? नहीं, बिकॉज दिस इज a single linked list. You can move in forward direction, not move in backward direction. So sir, you have to set one pointer here. You have to traverse. There is no other option. So again you have to traverse. The cost of traversal is order of n. So the cost for deletion is what, sir? Order of n. Understood? What about mid? You have to traverse half of the linked list. So this is the time complexity. All right. Now come to singly circular linked list, CSLL or SCLL. You can say either CSLL or SCLL. In singly circular linked list, circular singly linked list, last node next pointer will point to first node, student. The last node next pointer. So this is the data part, you know, no? Data part, next part. This is the data part. Next part here, this is the data part. And the next part. Last node next contain the first node address. So this is circular. Understood? This is circular. All right. Sir, in this circular, how we can detect this is the last node? Because this is a circle, this is a circle. In this circle, how you can detect, bache, this is which one is the last node, which one is the last point? How you can detect which one is the last point? Initially, bache, temp equals to self dot head. Initially, temp, this is take temp is a pointer and it contains self dot head. What is self dot head? 100. So this is pointing to this one. Now check while loop, temp dot next is not equals to self dot head. So temp dot next is 200 is not equals to self dot head. This is 100. Yes, sir, not equal. So temp equals to temp next. Temp equals to temp connects. All right. Again, this is a loop, student. Again, this is a loop. Again, go to again. Check this condition. Temp dot next equals to. So this is pointing to this one. Now check temp dot next not equals to null. Yes, not equals to self dot head. Bache. Temp dot next is 300. 300 is not equals to self dot head. Yes, sir. So again temp equals to temp connects. This is 300. So this is pointing to this one, right? This loop again. Go to this loop and check condition temp dot next not equals to self dot head. Yes, temp dot next is 400. It's not equals to 100. So this is again, sir. This is 400. So come at this position, right? Now check temp dot next is not equals to self dot head. Temp is next 100. Self dot head is 100. Both is equal. Condition false. बाहर निकलेंगे और देखिए टेम्प किसको पॉइंट कर रहा है? सर व्हेन दिस कंडीशन इज फॉल्स, when this condition is false, then temp is pointing to last node. Now temp is pointing to last node. right? You can check out here, temp is what, sir? 400. So temp is pointing to what, sir? Last node. So in this way, you can detect this is the last node, student. Now in circular linked list, I want to, sir, all same, all is same, but the last node next part contain the first node address. Okay. So insert at beginning, I want to insert at beginning in circular single linked list. Then how we can insert? What is the logic for this? What is the time complexity for this, student? When you insert, then you have to first allocate memory for a node, student. Okay. So allocate memory for a node. Let the data part of this is E, and the next part is what, student? Next part is none. Automatically, next part is none, and let the address of this node is what, student? 500, and new node is pointing to 500. कैसे allocate होगी? Yesterday we have discussed create object for node class, then automatically this memory allocated. All right. Now after this, first of all, allocate memory for new node, and after this, sir, if you want to insert at beginning, then you have to adjust pointer last node next part contain the address of this node, right? Then first you have to traverse and go to up to last node, student. You have only head pointer, so first you have to traverse from here to here, right? Traverse traverse, right? Traverse and set one pointer here, temp. This traversal cost is what, sir? Order of n. And after this, what you have to do is to set temp dot next. Because this is the first node, so temp dot next equals to what? क्या हो? It will become the first node. So temp dot next equals to what, sir? New node. Temp dot next equals to new node. What is new node? 500. So this connection disconnected, and this one is pointing to this one. This one is pointing to this one. Okay. And new node dot next, it becomes the first node. New node dot next. New node dot next, it becomes the first node, student. Self dot head. What is self dot head, student? Self dot head is 100. So look, so this is 100. Okay. So this one is pointing to. So this one is pointing to this one. All right. Okay. Now one more step required. One more statement required, student. What, sir? Self dot head equals to new node. Self dot head equals to new node. So self dot head equals to new node 500. So ये connector टूट गया, and this is pointing to this one. Okay. So in this way, you can insert at beginning, student. What is the time complexity for this, student? Is there any loop here? So what is the time complexity for this code, student? Is there any loop? No, sir. 3 constant operations. So this is constant, order of 1. Understood? The time complexity is constant. No, sorry, not order of 1. Not order of 1. Correct it. The time complexity for this one, and the traversal cost is what, sir? This is order of n. So total cost. traverse cost plus pointer adjustment cost. Sir, traverse cost is order of n and pointer or adjustment cost constant. So it will be, this is the time complexity, that is order of n. So in this way you can find, this is the logic, student. Okay. Now delete from last, student. In singly circular linked list, I want to delete from last. This is singly circular linked list. I want to delete from last, student. Then you have to set one pointer here, student, because this is a singly circular linked list. Then what you have to do, you have to traverse this linked list up to second last node, student, right? So first traverse the traversal cost order of n and set one pointer temp in this position. Okay. And then after this, what you have to do, sir, pointer adjust करना होगा. Sir, what, sir? Sir, temp dot next equals to what, sir? Self dot head. What is self dot head? Sir, this is 100. So you have to set this one. So this one is pointing to this one, right? This connection is break. Python garbage collector automatically free this node. Python garbage collector automatically free this node, entire node. So what is the time complexity for this? Sir, what is the time complexity for this statement? Sir, constant. So total time required traversal plus pointer adjustment. Traversal is, sir, order of n, pointer adjustment order of 1. So the time complexity is what, sir? Order of n. Right? So in this way you can delete from last in circular single linked list. Okay. Now singly circular linked list time complexity बच्चे, if only head pointer given, if only head pointer given, then sir, insert from beginning order of n. Why? Because you have to adjust last pointer, right? Next point, so you have to traverse linked list. So beginning हो, sir, beginning से delete हो order of n, end से insert, end से delete order of n. What about mid? Mid के लिए you have to traverse half of the linked list, so order of n. Okay. Sir, if both pointer head and tail pointer given, then what, sir? If both head and tail pointer given, if both head and tail pointer given, then, sir, beginning and mid. बताइए बच्चे. If both head and tail pointer given, then I want to insert at the beginning, sir, tail is given, so this is order of 1. I want to insert from end, sir, order of 1. I want to insert from mid के लिए you have to traverse half of the linked list, so order of n. Okay, this is order of n. What about delete बच्चे? What about delete? Sir, beginning से order of 1. What about this one? So this is a singly circular linked list. I want to delete from end, and we have both pointer, head and tail, both pointer given. then what is the time complexity for this? Sir, for this you have to both, if both head and tail pointer given, let's suppose, sir, both head and tail pointer given, then what? मान लेते बच्चे this is head and here this head and tail both pointer given. For both head and tail pointer given, for deletion के लिए, for deletion के लिए बच्चे head तो इसको point कर रहा है, head is pointing to what? Sir, head is pointing to this one. For deletion you have to set one pointer at the second last node. So is there any sir तरीका है कोई यहाँ से direct आप आ जाएं यहाँ पे? नहीं, because this is a single linked list, have only forward pointer, so you can move in forward direction. In single linked list you can move in forward direction, not in backward direction. So you have to set one pointer second last node. So you have to traverse. There is no other option. You have to traverse. So this cost must added, student. So the answer this is what, sir? Order of n, and this is order of n. Understood, बच्चे? No changes at ending operation. Okay. Now next is doubly linked list, student. My dear student, in doubly linked list contain two pointers, right? Previous and next. The node of doubly linked list, so three parts. So this is a this is the data part, student, and this is the previous, and this is the next part. And node look like this, student. Okay. So node have three parts, student. Node have three part. When I will create new node, इस तरह का कुछ create हो जाएगा. That this node have three part: previous, data, and next part. So this is the node class. Node class for doubly linked list, बच्चे. This is the node class for doubly linked list, right, student? So let's discuss first point. In the doubly linked list, every node contains two pointers pointing to the previous node and the next node. Okay, fine. B can traverse in both the direction. Okay, yes, in both the direction, because we have both addresses. Insertion and deletion will take more time because of more pointer updation. Okay, so this how we can create the node class, student. So yesterday we have discussed class node def underscore init under def underscore init underscore self comma data and colon here. Sir, when you create object of this class, node class, then automatically this constructor call, and data part is initialized by data, and next part is none, and previous part is none, right? Store the data pointing to the next node and pointer to the previous node, right? So when you create the object of this class, so I'm creating object of this class, then what will happen? New node is pointing to memory is allocated. So node data is A, and the next previous and next both is initialized to what, sir? None. Both is initialized to none. Now insert a new node at the end of the doubly linked list. I want to insert new node at the end of the doubly linked list. Then what is the time complexity for this, student? But during insertion, first you have to allocate memory for a node. Acha, thank you. Thank you, though. Yes. Sir, insert new node at the end of the doubly linked list. So when you insert node, then first you have to allocate memory for a node, student. First you have to allocate memory for a node. Okay. So, and allocate memory for a node, and the data part of, let I assume data part is E. Okay. And the previous and next part is what, sir? None. Right. And let I assume address of this node is what, sir? 500. And when you create a new node, sir, new node. So new node is pointing to, first of all, allocate memory for a new node, student. Okay. And after this, you have to just set this pointer. Sir, first of all, you have to traverse this linked list. You have to traverse this linked list. Understood? Because we are using only head pointer. We are using only head pointer. So first of all, traverse this node. And the next part of this node, contain what, sir? This new node address. New node address, very simple. And the new node previous contain this node address, right? It's very simple. Okay. Define def function insert at end self. So this is the function name, student. First of all, allocate memory for a node. How we can allocate memory for a node? So just write, sir, just write class name and data here. Just write class name. Then this node, this memory is allocated, and new node equals to. So new node equals to. So you are creating the object of this class. Then new node is pointing to this memory location, right? Okay, fine, sir. Very good. After this, such check is the linked list is empty or not? Dear student, if this condition is true, it means linked list is empty. If linked list is empty, then this node become the first node. This node become the first node, and self.head equals to what, sir? New node. Self.head equals to what, student? It is a new node, and return from here. So let's suppose this condition is false, then it means linked list already exists. Then you have to traverse, student. Then temp equals to sir self.head. Temp equals to self.head. So temp equals to self.head is what, sir? 100. So temp is pointing to this one. And apply loop and traverse, right? Sir, while temp.next is not equals to none, while temp.next is not equals to null, then temp equals to temp connects. So this is a loop, student. Sir, temp.next is not equals to null. Yes, 200 hai, so temp equals to temp.next. So this is 200. So now this is pointing to this one. This connection disconnected, right? After this, again go to this loop. Again check this condition. So temp.next not equals to none. Yes, temp.next is 300, not equals to none. Then temp equals to temp connects. So this is 300. So this is pointing to this one. This connection disconnected. Again, sir, while loop, temp.next not equals to none. Yes, this is 400. So temp equals to temp connects. So this is what, sir? 400. This connection disconnected, and this is pointing to this one. Again check, sir, temp.next not equals to none. No, sir, temp.next is none. Condition false. बाहर निकलेंगे. क्या करेंगे, sir? बाहर निकल के क्या करेंगे? Sir, temp connects. temp.next equals to what, sir? क्या हो जाए? New node. And sir, new node का previous, new node dot previous equals to what? New node dot previous equals to what, sir? Temp. So temp dot next, this is 500. So this one is pointing to this one. And sir, new node dot previous equals to क्या हो जाए, sir? 400. So this is pointing to this node, right? This node is added. What is the time complexity? Sir, here I am using loop bache. So due to this loop, the log cost is order of n. Here pointer adjustment cost is what, sir? Order of 1. दोनों को सम किया तो टोटल कॉस्ट इज व्हाट सर, ऑर्डर ऑफ n. सो द टाइम कॉम्प्लेक्सिटी फॉर दिस इज व्हाट सर, ऑर्डर ऑफ n. अंडरस्टूड? Order of n is the time complexity for inserting new node at the end of doubly linked list. Now बच्चे delete from beginning. I want to delete from beginning. This is a homework, try yourself, very simple. Okay, now doubly linked list time complexity बच्चे, if only head pointer given, then what sir? If only head pointer given, sir, then insert at the beginning, order of 1, no need to traverse. Sir, delete beginning from beginning, sir, order of 1. End के लिए you have to traverse entire linked list बच्चे, तो traverse करोगे तो order of n लग ही जाएगा उसमें. Sir, mid के लिए you have to traverse half of the list, right? So order of n by 2 is order of n. So this is order of n, right? Now sir, if both head and tail pointer given, then what is the time complexity बच्चे? क्या हो रहा है? चलो भाई बताइए. सर इफ दोनों पॉइंटर बच्चे गिवन हैं तो क्या होगा? इंसर्ट एंड डिलीट. इंसर्ट बिगनिंग से, सर इंसर्ट बिगनिंग से, सर ऑर्डर ऑफ 1. सर इंसर्ट एट द लास्ट, इफ लास्ट हेड टेल पॉइंटर आल्सो गिवन, सर दिस इज नो नीड टू ट्रैवर्स ऑर्डर ऑफ 1 बच्चे. बट फॉर मिड केस के लिए यू हैव टू ट्रैवर्स हाफ ऑफ द लिंक लिस्ट, सो n by 2 is order of n. What about delete? Sir, I want to delete from beginning, so this is order of 1. Sir, what is this student? This is a doubly linked list. This is a doubly linked list. I want to delete, sir, delete from end. Then what is the time complexity for this? Yes, student. Sir, this is a doubly linked list. And if both head and tail pointer given, if both head and tail pointer, sir, head is this position and tail is pointing to this position. I want to delete this node, right? You have tail pointer already. So PTR equals to, right here, PTR equals to what, sir? Sir, tail dot previous. Sir, tail dot previous say, sir, PTR is pointing to this second last node. No need to traverse. What is the time complexity? Sir, order of 1. Then after this, what you have to do? Sir, PTR dot next equals to what? Sir, PTR dot next equals to क्या हो जाए? Sir, none. Sir, PTR dot next equals to none. So this is connection is disconnected. Yes, this time is order of 1. So total time complexity is, sir, what, sir? Constant, order of 1. Understood? What about mid के लिए you have to traverse half of the list, order of n. So this is the answer. All right. Now next is circular doubly linked list. In circular doubly linked list, the first node previous pointing to the last node. First node previous, this is the data part, student, and this is previous, and here this is next part. Similarly, this is the data part, sorry, not data part. First node previous contain what, sir? First node previous contain last node address. You need no need to traverse, student. You can move in order of one time. बच्चे first node previous, you can move in constant time up to last node. समझे? And the last node next part contain the first node address. Sir, directly you can move in order of one time. Understood, student? Okay. Sir, I want to set one pointer, that is last pointer, at last node. What should I do for this? Sir, we have only head pointer, no tail pointer. This is a standard linked list, bache. We have only head pointer, but I want to set last pointer at the last node. Then what should I do for this, student? Sir, self dot head, sir, dot previous. So self dot head dot previous, very simple, sir. Self dot head is what, sir? Sir, 100. And 100 previous is what, sir? 100 का previous क्या है, sir? 400, right? So last pointer, you can set last pointer at the 400. So what is the time complexity for this is constant, sir. Constant. In order of one time, you can set last pointer at the last node. Okay, so no need to set tail pointer concept. Okay. Now, insert at end. I want to insert an end in circular doubly linked list. What should I do for this, student? During insertion, you have to allocate memory for a node. First of all, you have to allocate memory for a node. And the data part of this node, let I assume the data part is E. And the left and right. None. Okay, sir, done. Stack tomorrow. Will start, Sidhu. Stack will start tomorrow, not today. Okay. Just I'm going to end. Just give me sir, a half an hour, sir, 20-25 minutes more. Okay. Stack will discuss tomorrow, student, not today. So first of all, allocate memory for a node, student. Done, sir. So first of all, allocate memory for a node, and sir, last equals to self dot head dot previous. Last equals to self dot head dot previous. Then last one more pointer, last is pointing to this node. Now new node dot next equals to क्या करना है? Sir, new node dot next equals to what, sir? Sir, this node address, self dot head, right? And sir, new node dot previous equals to क्या करना है? Last. And last dot next क्या करना है? Sir, this new node एंड सेल्फ डॉट हेड इक्वल्स टू, ठीक है वही रहेगा ना, इंसर्ट एट एंड, नहीं, सेल्फ डॉट हेड डॉट प्रीवियस इक्वल्स टू दिस न्यू नोड. So find, so new node dot next equals to new node dot next is what, sir? Self dot head. Sir, what is self dot head? 100. So this is 100. Self dot head is what, sir? 100. New node dot next equals to self dot head. So this one is pointing to this one. Okay. And new node dot previous equals to last. New node dot previous equals to, sir, last. What is last, student? Last is 400. So this is 400. So if this is 400, then this is pointing to this one. Okay. Last dot next equals to new node. Last dot next, ये भी चेंज करना है, equals to what, sir? New node is what, sir? 500. So ये connection break हो जाएगा. This connection is break, and this is pointing to, sir, this is pointing to this one. Okay. And self dot head dot previous भी change करना है. This one you have to modify this one also. Self dot head dot previous equals to what? What equals to, sir? Previous equals to new node, बच्चे. So new node is 500. So this is 500. So this one is pointing to this node. Okay. All right, student. So this is the code, and what is the time complexity for this code, student? Sir, time complexity, sir, 4, 5 constant operation. So this is order of 1. Understood? So in this way you can implement. All right. Now circular W linked list time complexity, बच्चे. If only head pointer given, if only head pointer given, then what is the time complexity in doubly circular linked list, बच्चे? Beginning order of 1, ending is also order of 1, but mid के लिए there is no option. You have to traverse half of the linked list, right? So order of n by 2 is order of n. So this is order of n. Sir, if we have 2 pointer, is there any improvement? Nothing, बच्चे. Nothing improvement. हाँ. sir, beginning say sir this is order of 1, ending say sir no improvement, mid के लिए there is no improvement, you have to traverse half of the linked list, order of n by 2, order of n. So this is order of 1, order of 1 and order of n by 2. Order of n by 2 is order of n. Okay, so no improvement. Okay. Now this is the complete chart, bache. With all operation we have discussed in this linked list class, right? टाइम कॉम्प्लेक्सिटी ऑफ लिंक लिस्ट विद ऑल ऑपरेशन, बच्चे इससे भी क्वेश्चन आपका मिल जाता है गेट एग्जाम में. ओके, सो इसको देखिएगा. सारे केसेस वी हैव कवर्ड, एवरी केसेस वी हैव कवर्ड स्टूडेंट. सिंगल लिंक लिस्ट इफ आई वांट टू इंसर्ट एट फ्रंट मतलब बिगिनिंग, ब्रिंगिंग, मिडिल और एंड, और ये लिखा है इंसर्ट इफ ओनली हेड पॉइंटर इज गिवन, then this is the result. Sir, if I talk about single linked list, insertion if both head and tail pointer given, front, middle, and end, this is the result, student. Deletion with only head pointer, this is the result. Deletion with both head and tail pointer, this is the result, right? So similarly for this is for doubly linked list, this is for singly circular linked list, all right? Singly circular linked list, insertion only head pointer given, so this is the result. Insertion if both head and tail pointer given, this is the result, student. Deletion with only head pointer given, so this is the result. Deletion if both head and tail pointer given, then this is the result, right, student? Okay. So this table is important, student. Okay. No need to cramming, just understand all logic. We have covered all logic, sir, all the cases individually we have discussed. Okay, student. Now come to question answer portion. What is the answer for this question, student? Yes, student. Yes, everyone reply answer for this question. A is the right answer. Yes, बाकी के rest of student बताएं. This question is saying, sir, SLLDL be a function that delete a node in single linked list. Delete a node in single linked list, given a pointer to the node and a pointer to head of the list. हेड ऑफ द लिस्ट पॉइंटर और जो पॉइंटर डिलीट होना है वो गिवन है बच्चे. एस एल एल डी एल बी ए फंक्शन. सो एस एल एल डी एल क्या है बच्चे? ये एक फंक्शन है. ये क्या कर रहा है? दिस इज सिंगल लिंक लिस्ट. आई वांट टू डिलीट एक नोड, ये पॉइंटर गिवन है बच्चे, और दिस इज द हेड पॉइंटर. हेड पॉइंटर गिवन है. I want to delete this node, then what is the time complexity for this one, student? In single linked list के लिए, if you want to delete this node, then how you can access this previous node? You have to set one pointer at this place, so you have to traverse. So this cost is order of n. And after this, after this, just add this pointer and you can free this. So the time complexity for SLLDL is what, sir? Order of n. What about DLL, DLL, W linked list del this function? So this is doubly linked list. You can move in forward as well as in backward direction both. You can move in forward and backward direction as well as both. Sir, this pointer is given. Let QTR is given. Okay. and I want to free this node, then what should I do for this? Head is pointing to this one. Sir, I want to read this node, then you have to set one pointer. So sir, very simple sir. That sir qtr बराबर what sir ptr dot previous, because this is a doubly linked list. In order of one time में you can set one pointer qtr equals to this one. No need to traverse bache. So the cost for this is what sir? Order of one constant, and after this you have to just set just pointer. Just set just pointer and free this node. So it will take what sir? It will take sir order of one time. So which one is correct? Student option. SLL DL is order of n and DLL is this is order of 1. So D is the right answer, not A. Okay. So bache D is the right answer. SLL DL is order of n, DL is order of 1. Understood? Now consider an unordered list of n distinct integers. What is the minimum number of element comparison required to find an integer in the list that is not the largest in the list? Yes, student. What is the right answer for this question? Yes, student. What is the time complexity for this? This is a linked list. Suppose consider the unordered list of n distinct integer. What is the minimum number of element comparison required to find an integer in the list that is not the largest in the list? So in this question, you have to find the element which is not largest. You don't have to find the largest, right? You don't have to find the largest. You have to find the element which is not largest, right? So for which is not largest के लिए, you can take any two number. You can take any two student. Understood? You can take any two बच्चे. You can take this any two. Okay. Just compare 5 greater than 2. So 100%. This is a smaller number. Guarantee से sir, this is not largest. गारंटी है इस बात की बच्चे. कितना टाइम लगा सर? कांस्टेंट ऑर्डर ऑफ 1. सो कांस्टेंट यू कैन से 1. नंबर ऑफ कंपैरिजन is 1. Yes, A is the right answer for this question. Student, this question is visible. क्लियर है ये क्वेश्चन बच्चे? ओके, आई थिंक दिस क्वेश्चन इज ब्लर. कोई बात नहीं, इसको यू कैन ट्राई योर सेल्फ. क्वेश्चन इज वेरी सिंपल. एक्चुअली द कॉमन एलिमेंट उनको डिलीट कर देगा फ्रॉम L1 लिस्ट से. ओके, basically this code these two linked lists given, and what you have to do in this code, this question is saying कि this code, after this code is running, then consider the following C program है बच्चे ये. then modify the list L, the number of node in L1. सर कॉमन एलिमेंट डिलीट हो जाएंगे बच्चे, और कुछ नहीं चेंज होगा. सर कॉमन कुछ है इसमें, देखो कॉमन एलिमेंट डिलीट हो जाएंगे. क्या बचा रह जाएगा? कितने नंबर ऑफ नोड बचे रह जाएंगे? ट्राई, आप इसको ट्राई करिएगा. एक्चुअली क्वेश्चन क्लियर दिख नहीं रहा है, ट्राई करिएगा. Which of the following operation is performed more efficiently by doubly linked list than by linear linked list बच्चे? Which of the following operation is performed more efficiently by doubly linked list than by linear linked list? इस कोड के अकॉर्डिंग बच्चे चलना है, इस कोड के अकॉर्डिंग, राइट. तो क्या क्या डिलीट हो जाएगा? सर एक तो 12 डिलीट हो जाएगा इस कोड के अकॉर्डिंग, ये रहा 12. और सर 3 नहीं होगा, 9 है क्या इसमें? यस सर, 9 डिलीट हो जाएगा ये वाला. इसमें नहीं होगा डिलीट, इसमें डिलीट नहीं होगा, ये कॉमन है बच्चे इसलिए मैंने मार्क कर दिया. एंड 5 इसके अंदर है, 11 है क्या? यस सर, ये 11 डिलीट हो जाएगा. और 15, सर ये 15 डिलीट हो जाएगा. और सर 8 है क्या इसके अंदर? तो आंसर 5 आ जाएगा. आप इसको करना है, क्वेश्चन इज वेरी सिंपल स्टूडेंट. ओके, सो आंसर 5 होगा बच्चे. यू कैन ट्राई योर सेल्फ, वेरी सिंपल क्वेश्चन, कुछ नहीं है क्वेश्चन में. ऑल राइट. Which of the following operations perform more efficiently by doubly linked list than by linear linked list? Doubly linked list से कौन सा ऑपरेशन मोर इफिशिएंटली होगा एज कम्पेयर टू सिंगल लिंक्ड लिस्ट? बताओ. ट्रैवर्सिंग द लिस्ट प्रोसेस? नो सर, ये क्यों होगा? ट्रैवर्स दोनों में सेम तरीके से. इंसर्टिंग नोड आफ्टर द नोड विद गिवन लोकेशन? नो, दोनों में सेम होगा, सेम कॉम्प्लेक्सिटी. सर्चिंग अनसॉर्टेड लिस्ट ऑफ? नो सर. सो दिस डिलीट. हमने अभी देखा था ना SLL DL और DLL DL, ये जो फंक्शन था SLL DL सिंगल लिंक लिस्ट में ऑर्डर ऑफ n लग रहा था, DLL DL में कितना लग रहा था सर? ऑर्डर ऑफ 1 लग रहा था. सो आंसर इज व्हाट? डिलीटिंग ए नोड whose location is given, whose location is given. Understood? Understood? Now बच्चे टेल मी व्हाट इज द आंसर फॉर दिस क्वेश्चन. बच्चे ये सी का सीडो कोड है, राइट? यू नो सी प्रोग्रामिंग? डू यू नो लिटिल बिट कॉन्सेप्ट अबाउट सी प्रोग्रामिंग? बच्चे सी का सीडो कोड भी आ सकता है आपके गेट डीए पेपर में। लास्ट 2 ईयर से आ रहा है, गेट 2024 में भी आया है, गेट 2025 में भी आया है। ओके, सो सी का सीडो कोड भी आ सकता है, ऐसा मत सोचिए कि पाइथन में ही होगा, मे बी आ सकता है बच्चे। सो बताओ इसका आंसर क्या होगा। यस स्टूडेंट। Yes, what is the right answer for this question? Everyone reply. Uddhav is saying B. What about others? Consider the function defined. This function defined, this is a structure just like a node class हम बना रहे थे बच्चे, right? Look here, the logic here is student. Okay. P is pointing to the head of the linked list, head का एड्रेस आया। सर P equals to none अगर हुआ, so P equals to none. If list is empty बच्चे, then this is short circuiting. You know what is short circuiting? Or if first condition is true, if this list is empty, then no need to check it. This is short circuiting, and it return what, sir? 1. Understood? My dear student, if had अगर ये none है, right? इन सी प्रोग्रामिंग के टर्म में हम बात कर लेते हैं। बहुत मोटा हो गया ये, मैं इसको थोड़ा सा पतला कर लेता हूँ। P means just like a head बच्चे। If this contain what, sir? None. It means linked list is empty, right? P just like a P is pointing to जो P इसका हेड है, सो नन है, इट मीन्स कि लिंक लिस्ट एम्प्टी। और ये बच्चे यहीं से क्या रिटर्न कर देगा, सर 1, और रेस्ट ऑफ ऑल नो नीड टू चेक, और सभी जगह पे क्या हो जाएगा, शॉर्ट सर्किटिंग, राइट? सो इट रिटर्न 1। सो ये तो कंफर्म है, अगर लिस्ट में आपका एम्प्टी है तो ये रिटर्न क्या करेगा, सर 1 करेगा। ठीक है, दूसरा केस देखिए बच्चे। सर अगर ये सर P ये है और इसको पॉइंट कर रहा है, एक नोड है लिस्ट में, ठीक है, एक नोड है बच्चे, एक नोड है, डेटा मान लो सर 10 है, और इसका एड्रेस 1000 है। इट मीन्स व्हाट, सर लेट सपोज दिस कंडीशन फॉल्स बच्चे, दिस कंडीशन फॉल्स, दिस कंडीशन इज नॉट ट्रू, दिस कंडीशन इज फॉल्स, देन और ऑपरेटर check this condition, check this condition, p connects equals to what, p is 1000 connects equals to none और null बच्चे, none in python, in c में इसकी को क्या बोलते हैं, नल बोलते हैं, राइट? नल और इसका एक जैसा बिहेवियर है। नन कुछ और भी है, वो पाइथन के अंदर आपने पढ़ा था। सो ये रिटर्न क्या कर देगा, सर? दिस कंडीशन इज टू रिटर्न 1, एंड रेस्ट ऑफ ऑल केसेस नो नीड टू चेक, नो नीड टू चेक, दिस इज शॉर्ट सर्किटिंग, इट रिटर्न 1। सो कंक्लूजन ऑफ दिस स्टोरी, ये तो लिंक लिस्ट में सर एम्प्टी हो या लिंक लिस्ट में एक नोड हो, तो रिटर्न क्या कर रहा है, 1 कर रहा है, राइट? दूसरी चीज देखिए, दूसरा सर, let the address of this is 100 and this is 200 and 300 400 एंड 500 बच्चे, और ये नल है, एंड 200, so 300, 400 and 500. Okay, and P ये linked list है. Sir, P is pointing to this one. And linked list, this is saying what lists are sorted in non-decreasing order. Just like this value is 10, here 20, 30, 40 and 50. ओके अगर ये लिंक लिस्ट है बच्चे तो ये क्या बताएगा सर ये रिटर्न सर ये वैल्यू फॉल्स हो जाएगी नीचे वाली चेक होगी सर ये वैल्यू फॉल्स हो जाएगी व्हाट अबाउट दिस वन स्टूडेंट व्हाट अबाउट दिस वन सर p का डेटा इज लेस देन इक्वल्स टू p का डेटा इज लेस देन इक्वल्स टू p के नेक्स्ट का डेटा क्या ये जो डेटा है क्या ये लेस देन है इसके नेक्स्ट के डेटा से यस सर दिस इज ट्रू एंड ऑपरेटर में बच्चे एंड ऑपरेटर में क्या होगा सर ये रिजल्ट क्या आएगा सर ये रिजल्ट आया सर फॉल्स इधर देखो सभी लोग फॉल्स और फॉल्स राइट और फॉल्स यहां से क्या रिजल्ट आया सर ट्रू यहां से क्या रिजल्ट आया बच्चे ट्रू एंड रिकर्सिवली ये कॉल हुआ फंक्शन रिकर्सिवली फिर से कॉल हुआ किसके लिए सर एफ ऑफ किसके लिए कॉल हुआ सर एफ ऑफ पी का नेक्स्ट सर व्हाट इज पी नेक्स्ट सर 200 इसके लिए कॉल हुआ फिर से राइट सो फिर से रिकर्सिवली ये पूरा क्या देता जाएगा इसको रिकर्सिवली आप कॉल करेंगे तो ये रिजल्ट क्या आएगा बच्चे अच्छा ये रिजल्ट एंड है बच्चे यहाँ पे लुक हियर ये करेक्ट कर लीजिए इसको करेक्ट करिए 200 ओके तो बच्चे ये तो छोड़ दीजिए अगर अब इस पे डिपेंड करेगा ना रिजल्ट ओके सो ये रिजल्ट क्या आया सर ट्रू एंड सर 200 सर ये रिजल्ट क्या देगा रिकर्सिवली सॉल्व होगा सर ट्रू एंड ये रिजल्ट क्या देगा बच्चे सर ट्रू एंड सर दिस इज 300 इसके लिए कॉल होगा सर ये क्या देगा रिकर्सिवली कॉल हुआ सर ट्रू एंड सर एफ ऑफ सर 400 सर ये रिजल्ट क्या देगा सर ट्रू एंड एफ ऑफ व्हाट 400 की जगह आगे क्या आ जाएगा सर 500 सर ये रिजल्ट क्या देगा जब ये ट्रू होगा सर एक ही नोड होगा लिंक लिस्ट रिकर्सन एक ही होगा तो ये रिजल्ट भी क्या दे रहा है ट्रू सर ट्रू एंड ट्रू एंड ट्रू एंड ट्रू एंड ट्रू सो ओवरऑल इट रिजल्ट आल्सो ट्रू सो ये रिजल्ट भी क्या देगा बच्चे सर ये भी रिजल्ट ट्रू देगा तो सर आप बताओ कंफ्यूजन हो गया आंसर क्या लगाऊं माय डियर स्टूडेंट फॉर द गिवन लिंक लिस्ट p द फंक्शन f रिटर्न 1 इफ एंड ओनली इफ अगर ये लाइन नहीं लिखी होती बच्चे तो आपके लिए बड़ा आसानी होती अगर ये नहीं होता ये लाइन तो ये भी आंसर ठीक होता द लिस्ट इज एम्प्टी और हैज एग्जैक्टली वन एलिमेंट इस केस में ये भी आंसर होता बच्चे और द एलिमेंट इन द लिस्ट आर सॉर्टेड इन नॉन डिक्रीजिंग ऑर्डर सो ये भी आंसर होता राइट दोनों आंसर होते इस केस में अगर ये लाइन नहीं होती बच्चे अगर ये लाइन नहीं होती ठीक है तो आंसर क्या होता तो दोनों आंसर हो जाते हैं ओके बट सर ये लाइन तो है आप बताओ क्या आंसर होगा बच्चे अगर ये लाइन गिवन है इफ एंड ओनली इफ तो क्या अकेला ये स्टेटमेंट ट्रू है बच्चे द लिस्ट इज एम्प्टी और हैज एग्जैक्टली वन एलिमेंट क्या इसी केस में ट्रू है दिस इज सेइंग व्हाट इफ एंड ओनली इफ सो दैट्स व्हाई दिस ऑप्शन इज फॉल्स अंडरस्टूड नाउ द एलिमेंट इन द लिस्ट आर सॉर्टेड इन नॉन डिक्रीजिंग ऑर्डर इसमें दोनों कवर हो रहे हैं ए एंड बी सो मोस्ट करेक्ट आंसर सर बोथ केसेस कवर्ड इसमें आइदर लिस्ट इज एम्प्टी और सिंगल एलिमेंट और इन नॉन डिक्रीजिंग ऑर्डर सो बोथ इज कवर्ड सो दैट्स व्हाई आंसर इज व्हाट स्टूडेंट बी इज द राइट आंसर फॉर दिस क्वेश्चन व्हाट अबाउट सी द एलिमेंट इन द लिस्ट आर सॉर्टेड इन नॉन इंक्रीजिंग ऑर्डर गलत है right not all element in the list have same data value so this is also wrong so b is the correct answer for this question ओके यस इसलिए बी है इसलिए बी है क्यों क्योंकि ये लाइन लिखी है इसमें नॉन डिक्रीजिंग ऑर्डर ऑफ डेटा वैल्यू Understood, student? Now, what is the right answer? The concatenation of two lists is to be performed in order of one time. Which of the following implementation of a list should be used? दीपक सिंह, पीडीएफ गेट जीएफजी पोर्टल पे गेट सेट गो में जाइए, वहां आपको पीडीएफ मिल जाएगा दीपक सिंह। प्रीवियस जितनी भी क्लासेस हुई हैं जिसमें हमने पाइथन कवर किया है, राइट, सभी पीडीएफ आपको अवेलेबल मिलेंगी वहां पे। The concatenation of two lists is to be performed in order of one time. Which of the following implementation of lists should be used? सर अगर सिंगली लिंक लिस्ट ले लेंगे तो कितना हो जाएगा सर? ऑर्डर ऑफ एन। दूसरी लिंक लिस्ट को आपको ट्रैवर्स करना पड़ेगा ना। डब्ल्यू लिंक लिस्ट में भी ये क्या हो जाएगा सर? ऑर्डर ऑफ एन। सर्कुलर डब्ल्यू में सर ऑर्डर ऑफ वन टाइम में एक के लास्ट में आप चले जाएंगे, दूसरे का कंकेटनेशन कर दीजिए, राइट। So this one not true, this one not true. Array implementation of list, no, this is not true. Okay. Circular doubly linked list. All right. So C is the right answer for this question. Now, linked lists are not suitable data structure for which one of the following problems, बच्चे? दीपक सिंह, नॉट डब्ल्यू लिंक लिस्ट, डब्ल्यू सर्कुलर लिंक लिस्ट। अभी मैंने आज ही बताया है, टुडे इन टुडे क्लास वी हैव डिस्कस। ओके, so linked lists are not suitable data structure for which one of the following problem? Yesterday we have discussed this problem. क्या problem था बच्चे? Binary search, right? You know, if you apply sir binary search on linked list, then the time complexity is order of n. It is equivalent to linear search के बराबर होता है। So understood? अगर हम linked list पर binary search apply करते हैं, then the cost is order of n, and linear search की cost भी क्या है sir? Order of n. Understood? Sir, if both cost is equal, you know, so in this case linked list पर हम इसको प्रेफर नहीं करेंगे, क्योंकि ये दोनों का जब टाइम इक्वल आ रहा है तो क्यों अननेसरी हम ओवरहेड लेंगे, समझे? Binary search is a complicated code, a recursive code, right? It take a lot of stack space, it use system resources, very complicated. तो better है कि आप दोनों का आंसर फाइनली सेम है तो आप इसको यूज करिए, लीनियर सर्च। कल हमने डिस्कस किया था ना ये बात, कल बताया था, कल के वीडियो में सारी चीज़ें आपको बताई थी डिटेल में, रिकरेंस रिलेशन, टाइम कॉम्प्लेक्सिटी निकालना। सो द आंसर इज व्हाट सर? बाइनरी सर्च। पॉलिनोमियल मैनिपुलेशन तो इसी से ही होता है बच्चे, लिंक लिस्ट से ही। अगर आपने आपके सिलेबस में नहीं है इसलिए नहीं पढ़ाया है ये पॉलिनोमियल, पूरा पॉलिनोमियल एडिशन सब्ट्रैक्शन, राइट, ये सब इसी के थ्रू होता है। मल्टीप्लिकेशन लिंक लिस्ट के थ्रू होता है बच्चे, ठीक है। और इंसर्शन सॉर्ट तो आपका बेस्ट होता है, मर्ज सॉर्ट एंड इंसर्शन सॉर्ट। लिंक लिस्ट के लिए सुटेबल सॉर्टिंग कौन सा है सर? इंसर्शन सॉर्ट एंड मर्ज सॉर्ट, राइट। सो बच्चे दैट्स ऑल इन टुडे क्लास। बच्चे ऑप्शन डी का मतलब है पॉलिनोमियल एडिशन। पॉलिनोमियल में आप क्या कर सकते हैं? मैनिपुलेशन मतलब एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन किसी कांस्टेंट से, या टू मैनिपुलेशन, यही तो बात हम कह रहे हैं। पॉलिनोमियल का मतलब जस्ट लाइक ए 2x² + 3x + 5, राइट, इस तरह का पॉलिनोमियल लिंक लिस्ट से ही तो रिप्रेजेंट होगा। अंडरस्टूड? हम लिंक लिस्ट से रिप्रेजेंट करते हैं दो पॉलिनोमियल को ऐड, बट आपके सिलेबस में नहीं था इसलिए नहीं डिस्कस किया। अदरवाइज पॉलिनोमियल का एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन ये किससे होगा सर? लिंक लिस्ट के होगा। सो ये तो लिंक लिस्ट से होता है भाई। ओके, सो but this question is asking not suitable, not suitable, so that's why answer is what sir? B. Okay students, so that's all in today class. Bye bye, take care, see you again, कल मिलते हैं। ओके, आप अपने फ्रेंड्स को बताइए क्लास को ज्वाइन करें, क्लास चल रही है, डेटा स्ट्रक्चर की क्लास चल रही है, इज़ वेरी वेरी इंपॉर्टेंट सब्जेक्ट। सो कल सभी लोग आएँ और अपने फ्रेंड्स को बताएं। ओके स्टूडेंट, ओके, बाय बाय।